Hello, here we're going to look at 9.4, which will include the zero product property and also be called factoring to solve quadratic equations. So far we've been learning how to factor quadratic expressions. Right, we've factored in the past back in chapter 8. Factoring is going to come back, and we're going to see that as we move over into the other parts of these notes. So what we're going to do is we're going to take the knowledge and apply it to quadratic equations so that we can find our solutions. Right, in 9.3, we were looking for solutions. And here are some other words that meant the same thing. The most important one was x-intercept. X-intercept also meant the same thing as solutions. They'll also sometimes be called zeros, and they will sometimes be called roots. And we know that x-intercepts, which is what we're looking for, always have coordinate points like this. A number, comma, 0. That 0 is always there for an x-intercept. So if we want to find our x-intercepts, we will make sure our equations are equal to 0. Right? If our equations are solved equal to 0, we will be finding the x-intercept. So here's where the zero product property is going to come in. When we multiply two terms together, if one of them is 0, the answer will always be, and so what this is asking, if I pick any number in the whole world and I multiply it by 0, the answer will always be 0. So once we factor an equation, and if you remember, factoring involves taking a quadratic and splitting it up into two pieces. Right? We did this in chapter 8. We'd take a quadratic equation and we'd factor it into two pieces. What we're going to do is we're going to set up each piece equal to 0. And so I've got some examples of situations that have already been factored, and we're going to go through and we're going to find x-intercepts. So this has already been factored for you. These factors would have come from the equation x squared plus 2x minus 15. X squared plus 2x minus 15 would have factored to x minus 3, x plus 5. And remember, the way that the easy type of factoring worked was 5 and negative 3 had to multiply together to get the c term, and they also had to add together to get that middle term. So it's been factored for us, and to finish solving this, what we'll do is we'll take both pieces and set them up equal to 0. So I have x minus 3 is equal to 0, and I have x plus 5 is equal to 0. And then we solve. I'll add 3 onto both sides. On this one, I'll subtract 5 from both sides, and we'll get that x is equal to 3, and x is equal to a negative 5. So what that tells us is when we go to make a graph, we know for sure this has an x-intercept at 5 and an x-intercept at 3. And we could do other work with this to find the other points, such as the vertex and so on and so forth. But what we're focusing on is finding the x-intercepts, which are called the solutions to the equation. Here's another example that's been factored for us. We could solve it by setting up both pieces equal to 0. And the reason that this works is this property that we've been outlining this whole time of the zero product property. Right, let's go back and double check this. If I plug in a 3, 3 minus 3 is 0. 0 times all of that gives me an answer of 0. If we plug in negative 5 here, we get negative 5 plus 5 is a 0. And 0 times all of that gives me an answer of 0. So that's why this works. If we can figure out what makes both pieces equal to 0, we've found both answers. So let's do this one first. When I add 2 to both sides, I get that t is equal to 2. And if you think about it, that should work. Because if I plug in t of 2 right there, this piece would become 0. And 0 times anything else is 0. That's what makes t equals 2 a solution. And then for this one, we'd add 1 to both sides and divide both sides by 4. So this one would have solutions at 1/4 and t is equal to 2. Now, you may be confused up to this point about what this is all going to do. This is just a little bit of an introduction so that you could better understand the official 9.4 notes. And this is building off of 9.3. 9.3, if you recall, was solving by graphing. Here's how we did it. We'd ultimately be given an equation. We'd have to graph it, and we'd be looking for the two x-intercepts. And we did this by doing negative b divided by 2a, where b is 6 and a is 1. And that gave us the x-coordinate of our vertex. And then we put that into a table. We put the negative 3 right here. We would have gone in back to the original equation, and we would have plugged in the negative 3 to get a 9 minus 18 plus 8. All of this put together is a negative 1. And this would have been our vertex. Right, and you can see that matches with the picture. And then what we did was we extended our table in both directions. And we knew that since the vertex was in the middle, these two answers were going to be symmetrical, and so were these two. And we would have plugged in negative 2 or negative 4 to find the next piece of our table. I'm going to choose to use negative 2 because it's a smaller number. And when we did that, we'd get a 4 minus a 12 plus an 8. All this would have became a 0, which would have told us we have a 0 here and a 0 here. These two spots would have been our solutions because it's where y was 0 in the y column. And it was these 2 points right here. It was the x-intercepts. That's how we previously solved quadratics, is we'd have to graph, we'd have to do negative b over 2a, make a table, find spots in the table where a 0 showed up, graph it, take a look at it from a picture standpoint. All of that was a very long process. The zero product property is going to allow us to find the exact same answers, right? So this one's answers were when x was negative 4 and x was negative 2. We're going to be able to find those a lot faster with the zero product property. And here's how we would do it. I'm going to write back out the same original equation. We're going to do it by factoring. And then we'll compare how long each method is. So this is going to start off c and c. I'm now looking for numbers that multiply together to give me 8. Then also add together to give me 6, which would be plus 2 and plus 4. And remember, the order doesn't matter on that. And then the zero product property tells us to take each piece and set it up equal to 0. And then when you solve by subtracting 2 on both sides and subtracting 4 on both sides, you'll see that you get the exact same answers. Now in this one, I should have been using c for x, but same concept. You'll see that the answers are the same, negative 2 and negative 4. And if you compare the workload, you'll see that this method here is much longer than this method here. So that's what it's all about. It's going to be much faster to find solutions by factoring, than it is going to be by graphing. So if you didn't like 9.3 and solving equations by graphing, this method will be your other option in terms of how to solve quadratic equations. So what I've given you here is I've given you examples that have already been factored. So I'll do one more example and then let you try the bottom three. Remember, the zero product property is all about taking both pieces and setting them up equal to 0. And then solving. So on this one, I'd subtract 5 from both sides. On this one, I'd add 6 to both sides and then divide by 2. So these answers here would be -5 and 3. And you could check this by making sure that when you plug those back in, that you get zeros for both. Right, so I'm going to need to do this process twice. Let's plug the -5 in first. If I plug in -5, notice that this piece becomes a 0. 0 times that gives us 0 equal to 0, so it checks out. If we plug in the 3, you'll see that 2 times 3 is 6, 6 minus 6 is 0. 0 times all of that checks out as well. So you really just want to make sure that each x makes its own piece equal to 0. So here are 3 for you. I encourage you to pause the video, set both parentheses up equal to 0, and then solve. And then when you push play again, it's going to show you what the answers are. When you go through and set up all the parentheses equal to 0 and then solve, these would be the answers that you reach. And fractions are allowed, right? This fraction came from setting up 5k plus 1 equal to 0. First step would be to subtract 1 from both sides. Then the next step would be to divide by 5. So that's the good news, is that factoring allows us to solve very quickly. The bad news is you have to remember how to factor. But once with a little review, we should be okay on that. Remember that factoring is easiest when there's a 1 out front. And when there's a 1 out front, it's just going to start with whatever variable, so in this case x and x. And then I'm looking for numbers that multiply together to give me a -48. So that's to multiply to -48 and also add to -8. So I encourage you to think about that. What two numbers multiply to -48 but also add to -8? You can pause the video if you need more time to think. Hopefully you've come to the conclusion that it's going to be a +4 and a -12. Because +4 times a -12 gives us a -48, and +4 plus a -12 gives me the -8. So that's how we could correctly factor. And then we use the zero product property. So when I set up both pieces equal to 0, I can then solve very easily to get that x is equal to -4 and x is equal to 12. What we just found, in case you've been missing this, is we just found that this graph would have an x-intercept point at -4, and it would also have one at 12. We're finding spots on our curve, the ones boxed in red. Factoring and solving allows us to find x-intercepts. So let's try another. It's the easy type once again. So what you would do is start off x and x, think of numbers that multiply to -12, that also add to a +1. Those numbers would be a +4 and negative 3. And remember that the order doesn't matter. You could have put x minus 3 first. So then when we use the zero product property, we can go through and solve for both pieces. Very nice. Now, some things that are important to notice. All the times we've been using the zero product property. So that means if we're ever not set up equal to 0, that's an issue. We need to be set equal to 0 in order to use zero product property. So in this case, I'm going to need to subtract 12 from both sides. This problem here is the more difficult type of factoring. We know that because it starts off with a number out front other than 1. And the way that that works is you have to think about what are ways that I can get 2x squared. The only way is 2x and x. Then from there, we're looking for numbers that multiply together to give us a negative 12. So 1 and 12, 2 and 6, 3 and 4, where either one of them could be negative. But those numbers will no longer add up to the negative 5. Remember, on the more difficult type, those numbers do not also add up together to the middle number. To check the middle number, we instead have to check it by doing the smiley face method. So it's the O and the I out of FOIL. And we've been equal to 0 this whole time. And if you try different combinations, essentially in a guess and check process, you would eventually come here to 2x plus 3 and x minus 4. Because when I FOIL that out, 2x times the negative 4 is the negative 8x. 3 times x is the 3x. Those two green terms do combine together to give me that negative 5x. So that's how I know my factoring is correct. Which then means I can take both pieces and set them up equal to 0. So for this one, I would subtract 3 to both sides and then divide by 2. And we would get those as our answers. Now, if you had checked out some of the other videos that I posted about factoring, there is another method to do these more complicated types. The other videos I posted covered it. The way you do it is you multiply these two terms together and you'd get a negative 24 in terms of the numbers. So just the 2 and the negative 12. And then what that 24 allows us to do is think about numbers that multiply together to give us 24, that also will add up together to give us the negative 5. And keep in mind that one of these needs to be negative. And you might recognize, oh hey, it's this one. 3 and then minus 8 gives me the negative 5, and 3 times the negative 8 gives me the negative 24. But what you had to do after that was list those terms out like this, and then use factoring by grouping. So for this one, we could factor out an x. And for this one, we could subtract out a negative 4. And then the way this final process worked is whatever term showed up twice made a group, and the two terms that you pulled out made a group. And you'll see that we reach the same factored answer as we did, just kind of thinking about it logically, but that was another method on factoring the more difficult type. You don't have to do this way. You don't have to do this way. but you do need to be able to do one of them to successfully factor. Because if you can't factor, you don't know what pieces to set up equal to 0. Here's another example where before we start to factor, we do need to make sure to recognize we need to be set up equal to 0. So I'd have to add 36 onto both sides. And then we could factor. This is back to the easy type because there's a 1 out in front. So it's numbers that multiply to a 36 that add to a negative 12. It'd be minus 6 and minus 6. This was one of those special cases that would be the same term twice, so we could call it x minus 6 squared is equal to 0. So that means when I go to use the zero product property, I only will get one answer. All right, and what that looks like graphically, because we know we've been finding x-intercepts, is that this would also be the vertex. So this quadratic would look something like this. It would open up, starting with that one x-intercept there on 6. And we'll get more into this type of stuff as we move into the rest of this chapter. So that's the zero product property when you have to factor. I've given us an additional page here where they've already been factored for you, just to make sure that you're very good at setting up your pieces equal to 0 and solving. So this page here is just practice. So I encourage you to pause the video, go through and solve all these different pieces. There'll be 2 answers for each of them, and then push play again to compare your work. So here are the answers. If you were to set up each piece equal to 0 and solve, and you can double check them with your own work. Because if you were just previously successful factoring, but you don't know how to set up the pieces equal to 0 and solve, you won't be able to find the complete and final answers. And remember, what we're finding are x-intercepts. We're finding the 2 spots we cross the x-axis in a much faster method than graphing. So if you don't like factoring, it's probably still shorter and easier than going through the whole graphing process.